Following on from our look at variables, we're now going to talk about data types. We looked in the last video about how there are two main numbers in Python. So the two main numbers are integers and floats, also called reals more generally. So an integer is a whole number, something like 7 or something like -12 is an integer. There is no fractional part, whereas a float has this decimal point and a fractional part, something like 7.2 or -12.1. Has a fractional part, it's a float as opposed to an integer. Now integers and floats are two examples of data types. And data types are a really important topic in not only programming, also computer science more generally. So they're both examples. So we've got integers and we've got floats, two examples of data types, but both for numbers. These are not the only data types we have in Python. We also have characters, we also have strings, and we also have Boolean values as well. So let's talk about these one by one. A character is any letter, number or symbol. For example, A is a character because it's one letter on its own. If I press enter after typing an A, I get an error. It says name error, name A is not defined. So what it's doing here is it's expecting A to be an identifier. Effectively, it's expecting A to be a variable. So what you need to do is for characters, make sure you surround the character, the single letter, number or symbol, in quotes. So like this, double quotes or single quotes. You can see when I typed in the single quotes like that and pressed enter, it decided to make it into single quotes, which is fine. Either is okay. I personally do double quotes, but that's up to you. Same idea for numbers. If you want a number to be treated as a character, as in one snippet of text, I'd think of it as, you need to put it around quotes. If I just type in 5 and press enter, that also is fine, doesn't cause an error, because this 5 down here is an integer and this 5 up here is a character. Now for us as humans, the difference between this 5 and this 5 is just for quotes, which don't mean anything to us, but to a computer, the computer can do certain things with the 5 down here that it can't do with the 5 up here. Because it's treating this 5 with the quotes as a character, not a number, it can't do things like division or multiplication or using mod. So it needs to limit its operations to the data type. If I do something like 5 as a character divided by 2 and press enter, I get an error. It says we've got unsupported operand types for the division operator, str and int. So int is what this side is. So the two operands are effectively the bits of data either side of the operator. And the 2 is an integer and the str is a string. So we'll talk about strings in a second, but really it's saying that actually we can't do this operation on a character. It just doesn't know how to. Whereas 5 divided by 2, of course, will be fine. Get 2.5 because the two operands are of the same data type. Errors occur when you try to or mistakenly mix data types. Let's talk about those strings then, because they are really just multiple characters. So say hello, we did hello world before. Hello world, when it's surrounded by quotes, either double or single, press enter, that's fine, that is a string. So a string is multiple characters put together. Strings are the data type for text. If we did say hello on its own, press enter, again the name hello is not defined because it's expecting that to be a variable which hasn't been initialized yet. The data type dictates the operations we can do on that data, and so for example we could do hello divided by 2 again. This is going to also cause an error, this exact same error, because we can't divide a word by an integer. It doesn't make sense. Python is confused. It actually does let you do a few what look like arithmetic operations. So timesing by 2 will do hello hello. So Python has overloaded the operator, the asterisk operator, so it works with both integers and strings, but obviously in a different way. If I did hello as one word like that and plus world as a second word, the plus works. This operation is called concatenation, where we put two words together using the addition operator. But if I have different operands either side of that plus, if I do hello plus 5.5, hello plus a float, press enter, I get an error. It can only concatenate string, not float to string. So again, the errors have come from a data type being incorrect and inconsistent. The final data type is Boolean. So a Boolean value is either true or false. And so in Python, we have only two values, true and false. So they start with capital F and lowercase rest of the word, true and false like that. So those are the only two Boolean values, either true or false. And if you have done any binary, you'll know that computers represent all data as zeros and ones. And we have Boolean logic, and we can map this Boolean logic to zeros and ones. So true can be 1, false can be 0, and we can do lots of logic with this. So Boolean values are used a lot in programming, as we'll come across, such as in loops. We can also set variables to be Boolean values, as we can with any bit of data. So we could say something like, is password correct? And initially this is going to be false until the person has put it in. Then later, once they've put in a correct password, you can change that variable to be true. It's a good way of keeping track of various things in your code. Because these Boolean values are representing 1 and 0, if you do something like true plus false, you get 1, because true is representing 1 and false is representing 0. So 1 plus 0 is 1. So they are kind of like variables in that they are representing a value, but unlike variables, you can't change true to be 0 and false to be 1. They are set how they are. So in a way, they are sort of like constants. But that's getting into slightly shaky territory. I want to show you another useful thing regarding variables. So if I'm setting, say, a variable to year equals, let's say, 2000, I'm setting an integer to the variable year. And now I can do something like year equals year plus 20 to add to that value, and also save that new value, which is now 2020, under the name year. If I did something like year plus 20, that's great, but it's not saving the new value under the name year. Okay, so if I type in year, you'll see it's 2020, not 2040, because this 2040 was coming outside of that assignment. So we can use something called an augmented assignments operator to shorten this process here. We have something like year plus 20 is a bit repetitive. Instead, I can do something like year plus equals 20, and this will combine it, so it's sort of adding and saving the new value. So this should be, so up here it's 2020, this should now be 2040, because I've added 20 to year, which was 2020, and that new value 2040 has been saved under the variable name. You can do similar augmented assignments with the other arithmetic operations. So if we want minus equals 20, we could do times equals 20, and let's see what year is now, 40,400. It just shortens the process a little bit. Just to say one final thing about floats in particular, well, data types more generally are all about categorizing data. So some data is text, some data is numbers, some numbers are whole numbers. And this also determines how the data is stored in the computer. And all data is stored in binary, but it's stored in different ways. And floats in particular can be quite awkward. So something like 0.5 plus 1.2 gives us 1.7, which is fine. But if I do something like 0.1 plus 0.2, I should get 0.3, and I sort of do. I get 0.3 and a bunch of zeros and then a 4. And I mention this because if you play around, find this, it seems completely bizarre. The reason is because we are trying to represent this decimal number as binary, the computer has to store it as binary. And unfortunately, there's not just inherent to how the negative powers of 2 correspond to the negative powers of 10, there isn't always a way to completely represent the number exactly. So the computer needs to approximate 0.3 in binary, and so we get often a slight residue left over, usually a very, very small number, but it looks very weird. And the way you would fix this is by rounding. For example, we could round 0.1 plus 0.2, and then add a second parameter here of 2 places, 2 digits, and it gives us 0.3. We'll talk more about functions like this in future videos, but we have this left over. And this is not a huge deal once you understand what's going on and you are careful around it. There have been some instances where programmers haven't really understood what's going on, and so there have been major issues. But we are used to approximations in decimal too, thinking, 0.3 itself, if it's a third, we can represent a third as a fraction, but we need to cut off the 0.33333 at some point. We are used to approximations. It's a similar sort of idea here. Hi, as always, I'd recommend you pause the video now and try these exercises. The first two are just about, first of all, reading through these lines of code. So you've got one line, second line, third line, fourth line, they're running like that. Try and think about what the final value of these variables will be. So trace it through and see where the assignments are changing, and then try it yourself to see if you were correct. And 3 and 4, have a look at these two lines and see if you can figure out what the errors are and why the errors would occur.